All right, so let's start by learning some words. First, let's talk about, so this is section 2.5, and this is part 1. This section is broken into 2 parts. Right? First, we need to learn a few vocabulary words. Functions can be either odd, even, or neither. And the definition of an even function is when I put x in, I get the exact same thing out as if I put the opposite of x in. So examples of that would be like the absolute value. When I put 4 in, I get the same thing as if I put negative 4 in. Or a parabola, like x squared. Those are called even functions.
Can you say that again?
So an even function is when I put a value in and I get something out. Like if I put f of 3 in, I get 8 out. Then when I put f of negative 3 in, I get 8 out. So when I put the opposites in, I get the same number out.
So that's an even function.
That's an even function. An odd function is when I put
Looks funny.
when I put a value in and I put the opposite of that value, I get the opposite thing out. So in this case, it would be something like x cubed. That's considered an odd function. That's like if I put f of 2 in, I get 8 out. If I put f of negative 2 in, I get negative 8 out. So when I put the opposites in, I get the opposites out. But the same thing. Neither is just neither of these happen, right? And lots of examples of neithers. There's way more neithers than there are evens or odds. Evens or odds are not a complete set by any stretch. So just like the regular line, let's say y equals 2x plus 1, that is neither even nor odd. If I put 2 in, the way I can test that, if I put 2 in, I get 5 out. If I put negative 2 in, I get negative 3 out. So it's neither. They didn't come out as both 5 and they didn't come out as opposites. So has to work for everything. So you can easily test it by plugging a couple points in to see if it's even or odd. The next thing I want to talk a little bit about is increasing or decreasing. Increasing, decreasing, or you could have a constant. Let's take a look at a function that looks like this. I'm going to say that this is negative 5 right here, and we'll say that's 0. Okay. And I'll say right here is negative 3. Okay. All right, so if you look at this function, we always read them from left to right, just like you read a book. I am increasing as I go from left to right. I'm traveling uphill on the interval from negative infinity up to negative 3. That is increasing. And then I increase again from 0 to infinity. I don't include the turnaround points. And I'm not talking about the y values. I'm listing it by the independent variable, the x values. But between negative 3 and 0, I'm going downhill. So I'm decreasing from negative 3 to 0. Let's take a look at another example. Let's say I have a graph that looks like this. All right, so this would be, I'm increasing, going uphill from negative infinity to negative 1. And then, so I'm increasing here.
Will the graph show us whether you include 1 or not?
You never include the turnaround point.
Okay.
And then I'm constant from negative 1 to 5. And then from 5 to infinity, I'm decreasing.
So when it's constant, it stays on that
Stays on the
line.
same line. Yep. Constant.
So in these, you would never have a bracket.
Never have a bracket. Okay, and you know what the domain and range of functions are? There'll be a lot of domain and range questions. Again, the domain is the domain are numbers that go into a function. And really the trick for the domain is look for rational functions where you have an x or something on the bottom. Set the bottom equal to 0. It can't equal 0. Or the other place you'll have bad domains is when you have a square root, whatever's in the square root has to be positive. I'm just scrolling through here to make sure we catch everything that's on. Yeah. So almost all of your homework tonight is increasing and decreasing, even and odd, domain and range. That's all that we're working with for this evening. So I think that we have covered everything. I think difference
We did
quotient.
2.4 already, right?
If this is 2.5 part 1. Yep. All right. There you go. So here is an example. Suppose that h of x is equal to negative x squared plus 3x minus 6. And they want you to test to see if x is even, odd, or neither. What they ask you to do is tell you what h of negative x is. So if I put a negative x in here, what happens? So it would be negative x squared plus 3 times negative x minus 6. So that would be negative, and this would be x squared, which is x squared, minus 3x minus 6. So this would be negative x squared minus 3x minus 6. That's the answer they want for the first part of the problem. And then they want to know, is that even, odd, or neither?
That would be odd, right?
Well, if I look at here, if I pull out a negative sign from this, do these match?
No.
No, so it's actually neither. It's neither. It's
So
not
like-
even
like
or
an
odd.
An x squared would be even, right?
Why wouldn't you take the minus out of the 6?
Oh, I should have been plus, thank you.
So, even?
Neither still, because let me show you an example of one that's even.
I got it, yeah.
Let me show you an example of one that's even. Was one that it's close, but it doesn't match exactly. In either case, these don't match. And if I pull a negative out, it doesn't match. So it's neither even or odd. All right, real quick so that you can see what it is. What if I did h of x equals x squared plus 6? Then when I put in negative x in here, this would be negative x squared plus 6. A negative and a negative become a positive x squared plus 6. So these match. That's even. If I did it, let me show you an example of an example, odd one. If I had, let's do, I believe this one is odd, x cubed minus 2x. I think that's odd. All right, so if I do that, then I put in a negative x in here. I get negative x cubed minus 2 times negative x, which is negative x cubed plus 2x. If I pull a negative out of here, this is negative x cubed minus 2x. See how it matches exactly, except for this has a negative in front? That's an odd function. So what we had in